Okay, so let's just be careful with splitting things up, right? Because in order to take the antiderivative, you have to have x to a power. So I'm going to take the time to split this up. So x squared over 2x squared minus x over 2x squared plus 2 over 2x squared. So be careful with all these constants, right? So 1 to 2, I've not taken the antiderivative yet. These x squareds cancel, so I'm just left with the number 1/2. These one of the x's cancel, so I'm left with 1 over 2x. And the 2's cancel, so I'm left with a plus. And I'm just going to rewrite this as x to the negative 2. All right, here we go. Let's take the antiderivative. So the antiderivative of a constant is 1/2 x, right? This here, you want to think of it as negative 1 over 2, and then take the antiderivative of 1 over x, which is ln of absolute value of x. This, I'm going to add 1 to the exponent, so I get x to the negative 1 over negative 1. Now I'm going to do between 1 and 2, so I'm going to take the time to rewrite this term. ln of x minus 1, and then this will be minus 1 over x. Okay, so now I'm going to plug in the numbers. So if I plug in the number 2 here, that gives me a 1. Plug in the number 2 here, I get minus 1/2 ln of 2. Don't need the absolute value bars anymore once I put the 2 in because it's positive. Minus 1/2. And then I'm going to subtract off, plugging in 1. So I get 1/2. ln of 1 I know is 0, so minus 1. So all of this is my answer. Okay, so be careful with these. So let's again rewrite this. So this would be 2x to the negative 1/2. And this would be a minus 3/4 times 1 over x. So be careful to peel the numbers away from a 1 over x before you take the antiderivative and get the ln. So this is not ln, right? This would be wrong to say 2 times ln of root x. That's really, really wrong. Bad. Okay, here we go. So take the antiderivative, carry the 2. So I get x to the 1/2 over 1/2 minus 3/4 ln of the absolute value of x between 4 and 8. So I'm going to take the time to fix this. So we multiply by the reciprocal. So I get 4 x to the 1/2 minus 3/4 ln of x. Okay, so now I'm going to plug in. So I take this and plug it in. So I get 4 root 8 minus 3/4 ln of 8 minus, now I'm plugging in 4. So the square root of 4 is 2. So I get 8 minus 3/4 ln of 4. And that's a fine answer. This one here, we don't have a product rule for integrals, so you have to multiply it out. First. Okay, so here we go. So carry this along until you're done taking the antiderivative. So these multiply together to give you x to the 3/2, right? Because you add exponent, x to the 1, x to the 1/2. And then when I multiply these two together, the x's cancel, so I get minus 6 dx. All right, so let's take the antiderivative. So 3, I'd have x to the 5/2, and I'm just going to multiply by the reciprocal 2/5 minus 6x. And then I'm going to be taking it and evaluating it between 0 and 1. So if I plug in 1, I get 6 over 5 minus 6. And if I plug in 0, there's nothing there. All right, one more. So let's take the antiderivative of secant squared. So you know that's tangent of theta. Take the antiderivative of negative 2 sine. That would be negative 2 cosine of theta. And the antiderivative of 3 is not 3x, but it's 3 theta. Because I'm in d theta land, right? 0 to pi over 4. So I have tangent of pi over 4 minus 2 cosine of pi over 4 minus 3 times pi over 4. Now be careful with the 0. It's not always 0, right? So if I take tangent of 0 minus 2 cosine of 0 minus 0. Okay, so tangent of pi over 4, you know, is 1. This gives me, this 2 carries along. This gives me a root 2 over 2 minus 3 pi over 4. Tangent of 0 is 0. Cosine of 0, you know, is 1. So negative makes a positive 2. So there we go. One more I'm just going to add if I had 1 over e to the x between 0 and 1. You cannot take the antiderivative. This is not ln, so what is necessary is for you to rewrite it as e to the negative x. And then I'm going to think about how to take the antiderivative of that. Ooh, that's going to be challenging. Well, that's what we're going to be doing in the next section.